Oh my god, it's over! It's over! Oh my god! Oh my god, it's finally done! The EF-5 drought has been broken. No, I'm not kidding. I know I'm late to the party by like 2 days, probably. As it turns out, I'm actually late by like 2 weeks. So, yippee for me for being on time like usual, am I right? But I feel like it's warranted to talk about it, especially since I know that some people on, I don't know, Reddit, I guess, are very, probably dying to hear what I have to say. That was like the most obvious sarcasm I could do. On October 6, 2025, at 10:30 a.m. Eastern Time, an update was made to the rating of the first of the 2 twisters that hit near Enderlin, North Dakota, on June 20th, 2025. The first of which was upgraded from a 160 mph EF-3 to an EF-5 with winds in excess of 210 miles per hour. The weather community all at once went, "Say what?" And everyone started to lose their mind at what had just happened. The EF-5 drought, which began after the last EF-5 tornado, the deadly twister that struck Moore, Oklahoma on May 20th, 2013, has come to an end after 12 years, 4 months, and roughly 18 days. Or 12 years and 1 month if we were to count when the tornado actually happened. You probably have already seen and heard about it, and heard other people who actually matter in this space talk about it too. Which begs the question, what does the weeb think about all of this? Well, since you asked, and because rent is due, figuratively speaking of course, I want to talk about it and what this means for the future of tornado ratings. And for past ratings as well. This isn't a documentary, and before you ask, no, I am not planning on doing a standalone video on the Enderlin EF-5. If I talk about it, it will be because I talk about the derecho more likely than not. There just isn't enough extra information that I can add to the subject. The purpose of this video is to, 1, give you the most basic overview of what happened in a nutshell with the event, how it got rated EF-5, the reactions to the tornado's ratings, the criticisms of the decision, those exist but not directly related to it, and what this all means for tornado ratings going forward. This isn't a documentary, it's more so a commentary, a short one at that while I work on the second Katrina video. Which is still happening! So welcome to Nature's Yapping. So, June 20th, 2025 was a whack event even for this year's standards. Let's start out with this 500 millibar map. If you said this looks like a Ring of Fire setup, you'd be kinda right, actually. That was the main concern going into the night, a derecho more so than anything. You have a trough digging in from Canada, a stupidly powerful ridge over most of the country, coming together to create a healthy belt of mostly westerly flow into North Dakota, with easterly flow coming in at the 850 millibar level. At the surface, you had a developing area of low pressure near the Wyoming-South Dakota border, with a stalled frontal boundary and eventual warm front setting up in South Dakota, which lifts north over time. I would go further in depth, but looking at this map makes me not want to, so what else was expected? Storms would develop in central eastern Montana and progress eastward, growing in intensity and becoming supercells thanks in part to the high shear. With high instability, the threat of hail was also expected. The cells would congeal into an MCS, with the potential of a derecho forming across parts of the northern plains. Discrete supercells were possible ahead of the line, posing a strong tornado threat, if they could break through the cap. Turns out there was quite a bit of warm air aloft, making it difficult for storms to break through the cap, but if storms were able to break through it, they would be in an extremely volatile environment capable of producing strong tornadoes and large hail. However, those cells, if they developed, wouldn't last too long as the quick-moving MCS would come in and swoop them up. So a derecho with the potential of prefrontal supercells. You don't see that every day. Now that's over with, quickly, might I add, let's talk about how this event progressed. The storms that would eventually become the derecho formed in eastern Montana at around 5 p.m. Central, moving fast and rapidly developing. The complex was producing high winds very early on, as soon as 8 p.m. Central, with a 94 mile-per-hour wind gust recorded near Elgin, North Dakota. Just before dusk, 2 supercells fired near Jamestown, North Dakota, and soon began producing tornadoes as the derecho continued to bring wind gusts between 80 to 100 miles per hour across the south-central part of the state. The supercells were initially elevated, but the strengthening low-level jet allowed the cap to erode, and the storms began to ingest the strong storm-relative helicity within the frontal zone. There were a few tornadoes formed by the two supercells, an EF-3 near Spiritwood, and two EF-2s near Valley City and Fort Ransom. But just after 11 PM, the Enderlin twister touched down. Also, because this isn't in the Storm Events database, at least I think so, I'm not sure, government shutdown shenanigans, I'm just gonna paraphrase the narrative on Wikipedia. Not to mention, this isn't a documentary, this is me just talking about the implications of this more so than anything. The twister touched down at 11:02 PM Central Daylight Time about 4 miles south of Enderlin, rapidly intensifying and widening as it moved to the northeast, crossing over a CPKC railroad, derailing and tossing train cars a considerable distance away. It was here where the EF-5 damage was found, but I'll discuss that later. The twister continued traveling to the north before turning to the north-northwest, blowing over a cell tower, scouring the ground, and snapping and debarking trees. As it moved along the Maple River, the twister became violent once more as it completely leveled trees in a forest, with the debarking so severe it was like the trees were sandpapered. The twister continued to move to the northwest, snapping power poles, leveling more homes, before it quickly narrowed and weakened as it looped back to the south and lifted at 11:21 PM. The Enderlin EF-5 was on the ground for 19 minutes, traveling approximately 12 miles with peak wind gusts greater than 210 miles per hour, a peak width of 1.05 miles, and killing 3. When the tornado was initially surveyed, it was rated EF-3 160. According to chasers and those who saw the damage, they saw it and went, "Welp, that was definitely stronger than EF-3, most likely a tornado with EF-5 equivalent winds, yet again doomed to be underrated because of the lack of DEIs and being in a rural area." People were quick to note the train cars that were derailed, which I don't think I can show here, but here's a poorly illustrated diagram of it. After a day or so, people kind of just moved on to see the absolute absurdity that was the Northern Plains during June and July, but little did people know that damage analysis wasn't exactly done. Little did we know that meteorologists and engineers from across the space were Tylenol maxing. Little did we know that meteorologists and engineers from across the space were working together to do something interesting. Tim Marshall, Jim Ledoux, Dr. Miller, Dr. Greg Kopp, Dr. David Sills, and the Northern Tornadoes Project at the Western University's Canadian Severe Storms Laboratory worked together with NWS Grand Forks to do something that would have been seen as a cardinal sin to rating stuff on the EF scale. They were about to use contextuals not to keep a tornado from being increased with its rating, but to actually upgrade a tornado's rating. They worked diligently, I'd assume at least, for the next few months, and the results were published on October 6th at 9:30 AM Central. The public information statement started as following. Enderlin Tornado 1 upgraded to EF-5. So, before I talk about how the weather community responded to all this, let's just talk about what got upgraded, and as it turns out, it was more than just the EF-5 DIs that were introduced. Prior to this, many believed the only way a tornado would get rated EF-5 before the new scale comes out would be if a strong, violent tornado hit an area that was heavily up to date with modern building codes that would essentially guarantee an EF-5 rating. So, basically a major city or Greensburg, Kansas, which was really close to happening this year. Thank God it didn't. But you may also realize that Enderlin happened over what can only be described as the middle of nowhere. So, what happened? Random ass trade.
I like trains.
As it turns out, the trains ended up being the decisive DIs in question. What led the NWS to be able to do that was a study by Connell Miller, Gregory Kopp, David Sills, and Daniel Butt published last year, estimating wind speeds in tornadoes using debris trajectories of large compact objects. The conclusions in this report was a major factor as to why Enderlin got the rating it did. While it would be fun to decipher the technical jumbo, I just recommend reading the paper yourself, and watching my friend Jacob's video with Spark Service on the subject when it comes out, eventually. I feel like it's best to read the damage indicator often, almost in its entirety, to explain this. The tornado derailed 33 train cars, including 19 fully loaded grain hopper cars and 14 empty tanker cars, mainly tipped from the track. Included in the derailed cars were one filled grain car, around 286,000 pounds, and 4 empty tanker cars, 72,000 pounds, that were pulled into a field away from the track. Alright, since I began work on this, a little bit has changed regarding this DEI statement. There's been some skepticism as to whether or not one of the train cars was actually lofted or instead rolled. It does seem like that one of them was rolled, however the winds needed in order to get that rolling was at least 205, I think, miles per hour, so the EF-5 rating would still apply here. One of the 4 tanker cars was tossed 600 to 1,000 feet from the track, and an estimated 475 feet from the distance of the previous tanker car it was attached to before being pulled off of the track. Wheel sets detached near the point from which the cars were derailed from the track. It was in the trail derailment location that EF-5 damage intensity was noted, with greater than 210 mile/hour winds listed officially for this tornado. Analysis estimate potential wind speeds of approximately 230 miles per hour are needed to completely overturn a fully loaded grain hopper car. Collaboration with the Northern Tornadoes Project at Western University's Canadian Severe Storms Laboratory estimated a potential wind speed of at least 119 meters per second, or 266 miles per hour, were needed to loft the empty tanker car 475.5 feet, or 145 meters. The study, published in the Monthly Weather Review, found that large compact objects lofted greater than 50 meters indicate EF-5 intensity winds, greater than 200 miles per hour. The Enderlin train cars were nearly 2 times farther than the EF-5 threshold distance, and 4 times heavier than the heaviest object modeled in the study. Basically, they use this thing called math and science to come to this conclusion. June 1st, funnily enough, 2 days after the tornado pointed this out too, and came to an extremely close estimate of 264 miles per hour. He was off by 2. There were 2 EF-5 DIs, one for the heavy grain car and another for the empty one, but that wasn't all that was upgraded. Near 137th Avenue Southeast, a root ball from a tree row over a quarter mile away was lofted and landed near the street, with only 6 feet of the tree trunk remaining attached. It was upgraded to EF-4, 167 miles per hour. The debarked trees near the Maple River that were described as being sandpapered, upgraded to EF-4, 167 miles per hour. One residence that had all walls collapsed, upgraded to EF-4, 170. A house nearby that was swept clean, despite insufficient anchoring, upgraded to EF-4, 180. But the main takeaway was the lofted train cars. The last time a tornado got rated EF-5 due to contextuals like this was El Reno Piedmont in 2011, and the one before that was Joplin. Now, this begs the question, how did the weather community react to this news? The weather community at large was both shocked and also extremely happy over the decision. They were not happy about the 3 people that died, but more so that progress was being made on how surveys were being done. Now, you may be wondering, what's Alferia thinking about? Okay, but seriously, what are my thoughts on this? Thank the Lord! So, if you couldn't tell from my reaction, I have some thoughts about how I handled the scale in previous videos, and I want to address that first and foremost. I disowned most of the EF scale ran from 2023, might as well go ahead and disown all of it. While I think my heart was in the right place, or at least I think so, the way I went about it was in the stupidest, worst way possible. The only thing that still stands from that video that I can say I have no issues with is that when it comes to talking about tornadoes, the final rating is one of those things that I don't care about as much as the other aspects of a tornado's legacy. That still remains true. However, to basically yap for 50 minutes for what was essentially a nothing burger to get to that point was criminal. Okay, maybe that's a bit too harsh, but you get what I'm saying. In just about every video where it came up until the Joplin video, it was in the snob, ashhole-ish way of, you guys don't care about the lives lost. And really, I can only sum that up to the bigger issue here. And that is how most EF scale arguments, online anyway, end up being. Usually they devolve into what I can only describe as anime power scaling fights as to which tornado is stronger. If that sounds like something that is hard to take seriously, that's because it is. Again, the issue isn't the debate itself, something that I didn't really paint clear enough of a picture for. For the sake of science, these discussions must happen, and I've seen how on multiple occasions these discussions regarding a tornado's final rating can be done in a way that isn't tone deaf. Just look at the academic side of the community and you'll see it right away. These discussions happen frequently. It just so happens that the stupidest and most childish ones are often the loudest, like most things online. The EF scale in its current state is broken, but I think it's a step up from the Fujita scale in essence, at least. I think the scale needs to have some leeway and some room for contextual indicators, and for hard math and physics to play a role in determining a tornado's final rating, even maybe including Dow readings for a hybrid scale of sorts. I don't know about that one, though. But then again, that is a big question that I don't know how to answer as to how that would be implemented. But having practically no limitations with the sole exception of some basic descriptions doesn't work. Dr. Fujita is the most important person in tornado science, but having practically no limitations with the sole exception of some basic descriptions doesn't work. The Linden, Tennessee EF-4 from May 5th, 1999, if reanalyzed today, would be re-rated EF-2 or EF-3. The fun thing about the EF scale is that its purpose was to limit the issue of tornadoes possibly being overrated, which it achieved. That is a good thing, in theory. The problem is that the EF scale was too good at that job. This was known pretty soon after it became official. The problem is that the scale has been stuck in what I can only describe as bureaucratic how to figure out who exactly was in charge of updating it, and then in bureaucratic how when it comes to actually getting the new scale finalized. Now, with all that context covered, what do I actually think about all this? NWS Grand Forks did something really ballsy, and I think it paid off. Taking contextuals into consideration has been something that has been used to prevent some DIs from being upgraded. But I think using it in this case is exactly what the new scale should do, adding a new tool into a toolbox. It should be an addition to the original scale, which is how it was used here. By using additional research that has been validated by organizations like the American Meteorological Society, I have no problem with that research being used in tandem with the EF scale. Now, there's been some pushback to this. Tornado TRX put out a tweet that basically said that the reasoning for Enderlin's rating upgrade is an inconsistent standard for an EF-5 rating, and honestly feels quite unscientific when you compare the hundreds of extreme contextuals that you could apply this for in other tornadoes. I understand where he's coming from, but I sort of disagree, and it kind of boils down to one major point. At the end of the day, especially in comparison to other types of extreme weather, tornadoes are very inconsistent in nature. Now, we've gotten really close as to how tornadoes form and work, but on the same token, it's not definitive. How does a violent twister completely slab a home down to its foundation, but also leave the bushes less than 10 feet away intact? The answer would be that it was likely a subvortex, but you get what I'm saying here. How does that subvortex avoid the bushes entirely? The winds would still be pretty powerful to do that, right? Damage is our most consistent way of interpreting the potential wind speeds of a tornado. A subject whose wind speed is inherently inconsistent given the very nature of what a twister is. You could throw 1,000,000 Dows across the country, but that would be a waste of money. I feel like Will's argument here also puts serious doubt to the study that made the rating possible, which I recommend reading yourself. But it notably points out the issues with previous studies while also offering a new way to rate tornadoes based on train damage and vehicle damage. You know, something that everybody has been whining and complaining about, especially after Matador. It's either we are stuck with the same standard which has been pissing off the weather community for the past 12 years, or we actually try and change things to take more into consideration when rating tornadoes. I don't think it should be the end-all be-all here, but it should be an addition to how the EF scale is handled. On that topic, it's not just the train damage. Aiden, an engineering student at the University of South Carolina, conducted an analysis of the cycloidal markings on the twister which agree with the EF-5 rating. I'll link to the thread in the description, but to my very, very, very basic understanding of all of this, it does seem to be logically sound. But actually, cycloidal markings can't be used to rate tornado. Fujita did that himself back in the day. Also, I will bring up that many people instantly brought up Mayfield given how it tossed a coal-filled train car up a hill. However, the math and situation is very different, and it didn't take nearly as much wind to loft the train car. Now, this begs the question, what happens now? The events that have transpired over the past 2 weeks shows us that the Weather Enterprise is heading in a more interesting direction whenever it comes to tornado ratings. The original EF scale needed updates, and with known updates coming with more DIs and DODs, in addition to bringing in brand new peer-reviewed and analyzed research into the picture, helps us get a more complete picture. Again, no one tornado acts the same as any other one, so I think having a bit of leverage as to how to analyze tornado ratings was going to be needed at one point or another. Now, this begs the question, will the NWS go back and re-rate tornadoes when the new scale comes out, and based on new research? Well, apparently those talks as to how to handle it are happening as I am uploading this video. I feel like the biggest targets will be tornadoes that have happened in the past few years, basically 2020 onward. But I wouldn't be surprised if they go back further. This isn't a tier list per se, but what are the ones that I think will likely be given an upgrade, either to EF-5 or EF-4 based on that paper I just talked about, and the new EF scale. Tornadoes that I am 99% sure will get that upgrade. Gouldsby and Chickasha from May 24th, 2011, Bassfield So-So because of the tree damage, Rolling Fork, and Silver City from March 24th, 2023. This is the pretty sure category, so I have like an 80% confidence and these will be probably upgraded. Tuscaloosa Birmingham from Super Outbreak, Rochelle in 2015, the Western Kentucky Tornado from December 10th, Matador based on vehicle damage, and the Didsbury, Alberta EF-4. This is somewhat less confident, but there's still a chance, I would think, mainly because of tree damage. Either that or I don't have enough information to make any thoughts on it. Washington, Illinois 2013. Despite making a video on this, I don't remember seeing any rating controversy, but I think it's borderline, so I wouldn't mind if it gets upgraded. Mayflower, Valonia 2014. Would get the upgrade if one DI was needed. Otherwise, there doesn't seem to be enough close by to warrant it. But it's not out of the realm of possibility, and I need to do more research into this tornado anyway, so I'm not going to say anything about it one way or another. The Great Smoky Mountains National Park EF-4, Super Outbreak. EF-5 intensity based on tree damage from a study by Godfrey and Peterson. The Chattahoochee National Forest, Georgia EF-3, also from the Super Outbreak. Same study as before, which, if this was to be upgraded, it would be Georgia's first and only EF-5 or F5 tornado. Which, if it was rated based entirely off of tree damage, I'ma be 100% real, I would think that would be absolutely hilarious. This is the I have no idea and entirely depends on how the Dow is brought in tier. Okay, so in terms of everything that isn't Dow related, there's only one. New Ren 2011. That vehicle it lofted immediately gives it an EF-5 DI. But the bigger problem here, and the one that I think is going to be the biggest question the NWS will have to answer will be, is that enough? New Ren never got a formal survey, and that serves as one of the big hurdles, I think. It also may be a non-issue, who knows. Then there's the group that I like to call would only be rated EF-5 because of Dow measurements. Which, there's a lot, but that basically limits it down to Bennington 2013, El Reno 2013, Dodge City 2016, Chapman 2016, Alonzo EF-4 in Canada, Greenwood Springs EF-4, Scarth, Manitoba EF-3, Minden, Iowa, and El Dorado in 2024, alongside a lot more that I haven't mentioned here. The only tornado that I don't think would get an EF-5 upgrade based on previous comments would end up being the Henryville EF-4 from March 2nd, 2012. This was due to one DI where a pickup truck was lifted and never found with a backhoe deposited into the basement. It's the only area of EF-5 damage, although I don't think that it will get the upgrade. Okay, so a couple things about this list more so than anything. I really want to establish here that I really don't think that they're going to probably go back past 2020, with the exception of a very few select ones. I think Rochelle would probably be the most obvious one. I do want to adjust the list. Here is what it is right now as I look at it now. And again, everything before 2020 is kind of in a gray area. I do also want to mention that I didn't somehow mention Greenfield in all of this. That would probably go in between the pretty sure and the definitely near guaranteed that it would get upgraded. And the only thing that's stopping it is whether or not they take the parking stops into consideration. But really, that's it. Anyways, back onto this yapping session. But I also think that any tornadoes that I missed or ones that I forgot about could be done by universities and other research institutions, since I think for the most part, NWS offices may not be able to do all of that. Again, those are just my thoughts, and nothing more. The rating of the Enderlin tornado has, I think, kicked the door down on the obsessive strictness of the EF scale. Looking at what we know with Tim Marshall's paper back in 2022, there have been new DIs added, and others have been merged together. Something that has been acknowledged to have been needed shortly after the EF scale was created. But what I think is the most important part of all of this, based on what we have seen from Enderlin, is that from now on a tornado's final rating may not be completely limited to what is explicitly listed as a DI in the Enhanced Vegeta scale. Well, we already do that, but I mean to a more open and regular basis. Using hard math and science to figure out what winds were needed to loft something in the air, or do the level of damage it did. There are major hurdles to get this through, though. Starting off with previous tornadoes. We have to rely on what was taken shortly after the tornado happened. And while some tornadoes have a ton of data on them, including loads upon loads of images to dissect, the further back you go, the bigger that issue becomes. But that kind of comes with the territory. No, the biggest issue that isn't accounted for by everything I've discussed, the biggest variable in all of this, is the NWS office's ability to rate these tornadoes in the first place. No, I don't refer to NOAA cuts because that's not the issue. Although I did make a video about that whole debacle like 2 months ago if you want to watch it. Please, I put a lot of effort into that video. I need No, what I mean is that the practices and means of analyzing tornadoes does, to an extent, affect how tornadoes end up being rated. Now, for the most part, these biases are limited in part with the EF scale, and with the new scale, that should be limited further. But not every NWS office has the time or resources to 100% get engineers and a bunch of other people together to help out. This isn't to put shame on any NWS office in particular, but more so to bring up the valid point that NWS meteorologists aren't engineers. Like, I know, no shit, I am fully aware of that. It would be expected that EF-scale damage surveying wouldn't be as important to an office like, I don't know, NWS Flagstaff, Arizona, as it would be to NWS Birmingham, Alabama. Unless the date is October 7th, 2010, but I digress. For this to work, proper trainings with the new EF scale will be a must for just about every NWS meteorologist. And while QRTs do exist and help mitigate this problem, the local NWS office does have final say, at least from what I know. If there's anything else to add to this problem, is that given that there were already discussions between offices about how to reanalyze and potentially rate tornadoes in the past, I'm gonna go out on a limb and say that the issue of inconsistent surveys are probably going to be addressed too. The EF scale's future, mainly the new one, is looking like what it should have always been. A damage scale like how the original Fujita scale was. It was not a wind scale for everyone commenting on my original EF scale read who don't know how to read. Or listen, for a matter of fact. Now, with the potential for measured winds being used, and the high likelihood of using hard math and science to analyze how strong a tornado had to have been to tip over or loft objects, upon other stuff in the future that will be added. It's not inconsistent if this is the new standard going forward. And I think this is better than not doing it at all. Will damage analysis be more complex? Yes, most likely. But by using hard math and science alongside the new EF scale, I think we will be able to be as close as we can to being consistent with rating subjects that are inherently inconsistent in how they act compared to one another. But before I go to the credits, I do want to at least talk about the 3 deaths, because 3 people did lose their lives in the Enderlin EF-5. Michael Dane, a grandfather who was there to help those in need, a volunteer fire chief, an HVAC technician, and railroad worker. Catherine Paff Dean, a grandmother, retired U.S. Army veteran, who loved playing games and supporting her family. Macario Lucio, a painter and retired U.S. Army veteran who was remembered by those close to him as one of the nicest people they ever knew. May their souls rest peacefully in heaven. This is very likely going to be a tornado that the weather community doesn't forget. and it's one that I'm not going to forget anytime soon. Oh, yeah, I guess I am neglecting something. I do look a little bit different. You know, my makeup, I got a different brand. Okay, I'm bad at hiding this. So, if you haven't noticed, I look a little bit different in this video. I am no longer a PNG tuber, but now an O2D VTuber. Yeah, I'm like one of those big boys, but it's a simple model because it's mostly in line with Celtic White's art style. So, yippee. I want to give a big thank you to the person who made the model and rigged it, that being Barry, or Amberry, who I commissioned through VGen. They were amazing, and the finished product is phenomenal. I cannot thank them enough for how well it turned out. Not only can I have this detective outfit on, but I can take off the hat, or take off the overcoat, or, you know, both. And of course, for those who are wondering, I still have the OG design as a VTuber model. It's like this, and all that fun stuff. I love it. You may also notice that the detective outfit may be different too. Well, I finally got it commissioned and finished. This is the reference sheet that was cooked up by Celtic White, and it's so good, oh my god. Celtic White is a beast, and I cannot thank them enough for how well this turned out. From here on out, I think so anyway, this VTuber model will be replacing my stills going forward, and the detective outfit is staying. This one anyway. Now, for those wondering, while this is the first time I am showing it, a proper VTuber debut stream will happen at some point. I just need more time to get stuff together. Speaking of, I highly recommend following me on Twitch and on the second channel, Alferia Live. I've been streaming a lot more lately and maybe getting traction there thanks to you all here on the main channel. Don't worry, I'm not abandoning the channel. Yet. But I'm very excited to see how this goes. I also really want to thank Nyakubs and Vamrilla for finally pushing me into doing this. Without them, this would have been delayed until like 20-something, I don't know, probably not in the 2020s. Alright, time for video-specific stuff, and back to Audacity. Special thanks to my proofreaders, those being Foxtrot and Jacob from Spark Service, Celtic White for the character designs, Amberry or Barry for the VTuber model, Kelton Henderson for letting me use this photo of the Enderlin tornado, Aster for letting me use their icons, Zinno, Crackalick, and Cyanide Blue for letting me use their music, and everyone for watching. It means a lot. Special thanks to my patrons and YouTube members, those being Alan Boomer and Montpelier at the Ulfies Army tier, Michelle, Tanner, Techno Idioto, and Warm Off the String at the Ulf Junior tier, and Alto Stratamus, Bipolar Baddie, Brian Hawley, Carly Triplet, Dante DMC, Devin Mychan, Fry JC, Foxtrot, Hannah Stormer, Husky, James Sullivan, Kara Kelly, King Shisa, Liz Swaff, Means Beans Machines, Mama G, Rama, Southwest Florida Elevators, Tirani Rialta, Van Granny, and Will Morrill at the Ulf Mini tier, and everyone listed on screen at the Ulf Supporter tier. Your support is greatly appreciated. It helps me financially and will allow me to do more things in the future. So yeah, that's all I gotta say. If you liked the video, make sure to comment, like, subscribe, share it all around, all that jazz, and if you want to have more Alferia content for God knows why, like I said earlier, follow me on the second channel, also just all my socials, and also join the Discord server, because that is, in fact, a thing that I do own. I'm Alferia, you all stay safe out there, you all have a great rest of your night, and I will talk to you all soon.